let's talk about subshells. Each shell is said to consist of subshells, where subshells consist of atomic orbitals. There are 4 types of subshells called S, P, D, and F. For our purposes, we will be looking at the 3 subshells S, P, and D. We are going to take note here, and this must be learnt off, that an S subshell holds a maximum of 2 electrons. A P subshell holds a maximum of 6 electrons, and a D subshell holds a maximum of 10 electrons. Right, so given this information, which is the maximum number of electrons that a shell may hold, a subshell may hold, we can look at the arrangement of electrons in a shell in terms of subshells. So I'm going to draw a table. Right, so my table starts with a principal quantum shell, and we're looking at shells 1, 2, and 3. And we will look at the maximum number of electrons in each shell, which is 2 for the first shell, 8 for the second, 18 for the third. As established before, the first shell consists of an S subshell, the second consists of an S and a P, and the third consists of an S, a P, and a D subshell. We will now look at the names of the subshells in each energy shell. So for example, in the principal quantum shell, which is the first energy level, where we have a 1s subshell, we can go on to describe the subshells found in this level, right? So it's only an S subshell, but we will also use the principal quantum number with the name of the subshell in order to further help us focus in on the characteristics of an electron, meaning that we are now kind of zoning in on the size, the shape, and the orientation of the electron when we speak of it in terms of its location, that is, its subshell. So for example, the subshell found in the first shell is called 1s. If we have an S and a P subshell in the second level, it will be called 2s and 2p. Can you name the subshells found in the third shell? Yes, it's called 3s, 3p, and 3d. So let's take it a little further. I'm going to introduce to you an idea which you're going to have to accept and understand, which is that an orbital can only hold 2 electrons. right? Or that no more than 2 electrons can exist in an orbital. Right, so we're saying that an orbital can only hold 2 electrons. And remember what I said about a subshell. We say that a subshell consists of orbitals. So let's start with our S subshell. We say that an S subshell can only hold a maximum of 2 electrons. So how many orbitals do we expect to find in an S subshell? We'd only find one orbital in an S subshell. If we say a P subshell can hold a maximum of 6 electrons, given that an orbital can only hold 2 electrons, how many orbitals do we expect to find in a P subshell? Right, so 6 divided by 2 gives me 3. And if a D subshell can hold a maximum of 10 electrons, how many orbitals do you expect to find in the D subshell? You're going to find 5 orbitals. Alright, so we say that the S subshell consists of 1 orbital, the P subshell consists of 3 orbitals, and the D subshell consists of 5 orbitals. As such, can we now go on to figure out how many orbitals are present in each shell? Alright, so let's look at the number of orbitals. So for example, in the first shell, which consists of a 1s subshell, how many orbitals are we going to find? Only 1. In the second subshell, where we have an s subshell, we're going to find 1 orbital plus in the 2p subshell, we're going to find how many electrons? Let me just start over. In our second shell, we are saying that we're going to find a 2s subshell or 1s subshell, right? So that means we have 1 orbital in this s subshell. In the p subshell, we're going to find 3 orbitals. So this is 3. And in our third shell, we're going to find 1 orbital in the s subshell, 3 in the p subshell, and 5 in the d subshell. Alright, so I'm going to tally up my numbers here. By looking at the total number of electrons, right, within each within each shell. So in our 1s subshell, we'd have a maximum of 2 electrons. This corresponds with the maximum number of electrons in the first shell. in the S subshell that we find in shell number 2, it would contain 2 electrons, and the 2p subshell will contain 6. In the third shell, in our 3s subshell, we have 2 electrons. In the 3p, we'd have 6 electrons. And in the 3d, we'd have 10 electrons. If we add up these numbers, it adds up to 18. And this is looking at shells, subshells, and number of electrons. So just to recap once more, we say that a shell consists of subshells, where the first shell consists of an S, second S and P, third S, P, and D, where each shell holds a certain maximum number of electrons, and this is because each type of subshell can only hold a certain number of electrons, S containing 2, P 6, D 10. Each shell consists of a different number of subshells, where if we add the number of electrons found in each subshell, this will give us the total number of electrons found in total in a shell, which is, for example, 2, 8, 18. But we must understand that a subshell consists of orbitals, where each orbital can hold no more than 2 electrons.